So on number 3,
let me get there in just a sec. I'm going to run through problem 1 with Addie. You're fine, and then I'll get right to you. So assignment number 49, problem 1. So what I see is that there are some x's on top and there are some x's on bottom. And so we're just going to use the subtraction rule, which says to take the top x, his exponent, which is -3, and we're going to subtract the exponent on the bottom x, which is -1, and -3 plus 1 is -2. You with me so far? So that means that when we write our answer, we're for sure going to need a fraction. Like if everything in this problem wound up in the top, then I would be like, I don't need a fraction. But I know now that I need a fraction because there's going to be x to the power of 2. But I'm going to put it in the bottom because this told me to put that downstairs. You with me so far, Addie? Okay, and then the y to the 4th just sits there and doesn't move, and that's it. Like, you're done when there's no, if you can find x's and y's in more than one place, you're not done. If you can find numbers that need to be reduced, you're not done. But in a case like this, that's just dead. Good. Okay. Did you guys say number 3? Is that correct? Mm-hmm. So problem 3, if I want to always get rid of parentheses first. So I'm going to take the first y to the second and turn it into y to the 4th. And then the other y, I'm going to multiply his exponents and make him y to the -8th. And then that's all going to go over y to the 3rd. The idea with this, and you'll figure this out, is you really just have to treat the top like its own math problem and the bottom like its own math problem. So like the top is a thing. I have to do it. And to do it, I have to add the exponents together. So 4 plus -8 is -4, right? So we're not letting the top and the bottom interact yet. We're just adding the two exponents on top. No, it's plus because they're next to each other. We're not subtracting. So 4 plus -8 is -4. So we have y to the -4th over y to the 3rd. And once we get to this point, our only option now is to identify that, okay, there's some top and bottom guys that are the same. And now is when we do subtraction. So we have to take the exponent on top minus, because we're going downwards now, we're dividing, so we subtract, minus the bottom exponent, which is 3. And -4 minus 3 is -7. So that tells me in my final answer that, again, I need a fraction, kind of like what I told Addie. If you know you're going to have something, then you need a fraction. And so all of the y's basically wind up joining forces, and there are 7 of them. They all join forces in the bottom, and there's nothing left on top, so we have to put a 1. Right? Yeah, so the moral of the story is generally going to be treat the top, do it completely, complete it like a math problem, simplify it completely, simplify the bottom completely, and then work downwards. Yeah. Mm-hmm. Uh-huh. The end, you mean the end of the 3rd at the end? Yeah, so oh, let's go through it. Is that okay? Just go through the whole thing. So this is assignment number 48, and this is problem number 15. And I have m to the -3 times n to the 0 over 3 m to the -1 n to the 3. So the first thing I'm always going to do, and this hasn't applied to either Addie's problem or Ms. Roscoe's problem, because all they had in their problems were just variables, like no numbers. But we have a number here, and it's right here. And it has no one to go with. It has no one to reduce with. It has no exponents, no negative exponents. So I can already say for sure that the final answer will have a 3. Like that's not, we agree, right? Now, the other thing we can do to simplify our lives is we can identify that this really amounts to nothing. What does that equal again? What's that? Well, it does equal something, but it doesn't have any value in the problem really. Like it doesn't affect anything, but it does have a name. What is anything to the power of 0 equal? You can add it back in right now if you want. Anything with a power, an exponent of 0 equals 1. You're going to want to know that because when they pop up, think about it like this. Imagine if I took out this yellow thing and instead I changed it instead of into times n to the 0 if I put times 1. Like, you know, in math that multiplying by 1 doesn't mean anything, right? So what we can essentially do is just get rid of it. Okay, so don't think that it doesn't equal anything because it does. It's just what it equals doesn't have any significant impact on the problem. Got it? Okay. So now what we're going to do is we're going to look across the top and say, okay, there's nothing I can do on the top. We're going to look across the bottom and say there's nothing I can do on the bottom. And this is where we're forced now to start letting the top and the bottom simplify together. Do you understand that? It's like with equations, how we work on the left side and we work on the right side. But once like the left and right side are done, that's when we have to start like moving 5x to the other side. Like that's what we're doing here basically. So the only thing that I can do is recognize that there's some of those on top and some of those on bottom. And that means we have to subtract the exponents, right? So what is -3 minus, it's always minus if we're going down, -1. It's not. It's -3 plus 1. Be right with you. So the fact that the answer for the m's, like this is m's number. M says -2, my guy. That means we're going to put in m to the +2, but where are we going to put it? Not if it's negative. Yeah, the sign of this answer, if this answer that you get comes out positive, then you put it on the top. But if it comes out negative, then you put it on the bottom, right? Make sure you also add that to your notes. That's what we're at that stage of the problem where we know like we so this number when we do our subtraction, and please use your calculator for that. Okay, you can't be okay, good. So minus a negative plus, we get -2. So the fact that it's -2 means we're going to put in, this is important, we're not going to put in m to the -2. We're going to put in the positive. If that comes out negative, don't put it in negative, put it in positive. But when you put it in, like you have a choice. Should I put it up here, down here, up here? And if it's negative over here, then you put it down here. Got that? And then I also look at the final guy and I'll make him yellow. And I say, like, this guy is, it's what I call a straggler. He has no one to go with. He just sits there. And so because it's a positive exponent, I'm just going to leave it where it is. I'm not going to move it to the top. I would only move it from where it's currently at if it were negative. So it just sits there and it just goes like this. And then you look at the problem and say, okay, the 3 was downstairs. The m's wound up downstairs. The n just stayed downstairs. There's nothing upstairs. So we need, got it? What are you waiting for over there, guys? Yeah. I assume you're on the new one today? Sure. Number 4 today? 4? So, I mean, we're just gonna, some people, you're not allowed to call it this, but some people think of it as combining like terms. That's kind of what it boils down to. So when I go through this problem, I just look for parts that need to go together. Basically, the way it works is numbers go with numbers, A's go with A's, B's go with B's, so on and so forth. So like I look through, and the first thing I scan for is the basic stuff that has nothing to do with ninth grade, and that's just these guys, 3 times 2. You understand that this does not say 3b. You get that? That's really, really important. The 3 is his own guy. So when the 3 and the b, or the 3 and the 2 multiply together, what do we get? Okay, so we know for a fact that our answer is going to look like this. The question in my mind right now is, am I going to need a fraction? Like, and I generally don't put the fraction bar like you could and then erase it. But the question is, am I going to wind up with anything downstairs? If I do, I need a fraction. If I don't, then I'm just going to have a thing, an answer, right? So let's do the A's. And since they're side by side, I'm going to look at their exponents and say, well, let's see. There's 3 of you here, and there's -3 of you here. And since they're side by side, what do we do with the exponents? We add them. That's important that you know that when we go sideways, we're adding. When we go downwards, we're subtracting. And you guys know that 3 plus -3 is 0. Whenever that happens, you can put 1 if you really want to. But I mean, just think about like, and I don't disagree. Okay, so you say, okay, 3 plus -3 is 0. So you got a to the 0th and it equals 1. But stop and think for a second about how weird it would be to put a 1 in there. Like what purpose does it serve? Literally none, right? So whenever this happens, I heard one of you a minute ago say the word cancel, and that really effectively is what happens. Is this a to the third and this a to the -3rd, they basically just wipe each other off the map. Got that? There needs to be no evidence of them when you're done. Clear? Now let's go to the b's. And when I look at the b's, I see that they each also have exponents. What's the exponent on this b? It's important. Again, these are all things that this is why we practice in this class so much, is because yes, Brendel, very good. There's a 1 there that you can't see. And people sometimes say it has no exponent. I'm like, I gotta cry foul. That's not true. Ones cause a lot of troubles in math because we don't see them, but they're there. And so if I take the exponent of this b, which is 1, and I add the exponent on this b, which is -1, once again, what's 1 plus -1? 0. And so I can say to myself again that this b and this b wipe themselves out of existence, leaving the answer as just 6. No one survives because all their exponents just go crash, cancel, done. Piece of cake. You're welcome. Yeah. Mm-hmm. If it starts on the bottom as a negative, I would move it to the top, but you got to be careful. Tegan, I'll be right. I'm going to answer your question in just a second. So I'm about to do problem 49, number 6. But the thing is this, if I had a problem where I had like, I don't know, I'm just going to throw some stuff in here. If I had like x to the -2 and like x to the -5, I would not move that to the top because I this is always the hardest part for me, and I'm always thrilled when this finally happens and clicks and you guys get what I mean. I'm not going to move it yet because it has something else it can do. It can interact with another x. So I don't know what problem you're looking at, but like in the one I have on the board, I would not move anything. What I would do instead is I would just do my basic math, and I would just do -2 minus -5. And what would I get? Don't you start with me. Come on, it's too early for that garbage. -2 plus 5 is not -7. Good, it's 3. And so because I get 3, then what winds up happening is both of these x's essentially sacrifice themselves And so at the end of the day, I didn't really quote unquote move anything. I just combined the ones on top and bottom and wound up with that. Do you understand that? So I would only move something if it's the only version of itself left in the answer, right?
Like pretty much just simplifying.
Right. But if you look and see like a y to the something and a y to the something somewhere else, use your properties first and only move things as a last resort. That makes sense. So problem 6 is yeah, that's an interesting question, right? I don't think we didn't have any of these in our notes. So you guys all should pause for a second. I know that I don't mean to interrupt, but has not come up yet. And honestly, it's odd. I had the computer generate these randomly. It randomly generated 2 of these in a row. 6 and 7. What are the chances of that? So number 6 has a big set of parentheses and it has an exponent on the outside. What number 6 really could have been written at if the computer had wanted to is it could have written it like 2x y to the fourth times 2x to the negative second to the second over 2x to the negative third to the second. What I'm trying to say to you is that when you have a big fraction with a power of 2 outside, the power of 2 distributes to the top, but it also distributes to the bottom. Does that make sense? So that's what this winds up looking like. So we'll still press on, but I want you to know that to begin with, that massive like king cheese exponent outside, if he's an exponent on a fraction, he goes everywhere. Got it? You want to continue? Okay. So as always, I'm gonna worry about my parentheses first. So before I worry about the distribution, you remember this from yesterday? I'm gonna combine everything I can in there. I'm gonna clean that up. You don't, I would not, I'm not saying that it's wrong if you don't, but I would never distribute into something that could be a better, cleaner version of itself. I like to tidy things up and then distribute, right? So in the top parentheses, I'm gonna take my 2 and my 2 and make 4, right? Just multiply, old school. And then how many x's are we going to have in the top if we go sideways? You -1. Very good. And you didn't fall for the invisible exponent. Good for you. You're getting the hang of this. This is x to the 1. You can't see it, but it is. And 1 plus -2 is -1. And we're not at the stage of the problem where we're worried about, oh, it's negative, put it on the bottom. We're just tidying up right now. That's all we're doing. And then how many y's are we going to have? Right? Because he has no one to go with. So we're just going to have y to the 4. And then I'm going to stick that exponent out there. And as annoying as it is, I'm going to recopy the bottom. Where you see an x to the 4th? We're on problem 6. Yeah. So you ready now? So on the top, the exponent, every time you're ready to say, okay, I'm going in, you have to ask yourself, how many jobs does this guy have to do? And the answer to that is how many entities are inside? 3, right? There's a 4, there's some x's, and there's some y's. So the 2 has triple duty. The 2 says, first, I'm going to go to this 4. And what is 4 to the second power? Nice job, 16. And then I'm going to do the 4, or the 2, excuse me, to this. And that's going to just give me an x to a new power. What's the new power? It is, because you multiply. Nice job. Yeah, if they're side by side, like if you have an x to the 4th, and then somewhere later down the line, side by side, you have like an x to the 2nd, that's where you would add them to get x to the 6th. But if you had an x to the 4th, and then there was a king cheese exponent coming in, it's a different property of exponents. That's the one where we would multiply them and get x to the 8th. You with me? Okay. So that leads us then to, and you already said the answer. So for the x's, we have -1 times 2, which is -2. And then what's our y power going to be? Y to the what? Mhm. And that's just because right here in this little yellow box is a multiplication problem of 4 times 2, right? Good job. So we survived the top, and now it's time to go and clean the bottom. And how many jobs does the king cheese exponent have to do on bottom? Right. So he'll distribute to this 2, giving us what? Good job. 4. And then he'll also distribute to this x, giving us x to the -6. So we've accomplished our objective. We cleaned the top completely. If I asked you to combine more on the top, you'd say, don't, I can't, I'm done. Same with the bottom, right? So this is the part of the problem. Like I was telling Cambry, it's like solving an equation where you've simplified the left side and simplified the right side, and you go, okay, I guess now it's time for me to add 3x to both sides and subtract 4. This is where we have to start letting things interact. It's the only way to put things together. So we always want to begin with the little elementary school part, and that is, this is not 16 minus 4. It's just what you learned in 4th grade. Reduce 16 fourths. What do you get? 4 over 1. And I choose, and I hope you make this choice too, I choose to never, ever on purpose put ones in the bottoms of fractions. So I'm just going to put it like this. Putting ones in the bottoms of fractions is a really weird habit. Don't do that. Got it? Ones in the tops of fractions. Ones in the tops of fractions are sometimes necessary, but bottom, never. So let's look at our x's now. I have a subtraction problem to do. I have some x's upstairs and I have some x's downstairs. What is negative? God, I keep doing that. What is -2 minus -6? It is all day long. -2 plus 6 is 4. And since it's +4, then I choose to put my x to the 4th on top. I shouldn't even say I choose, like that's what I have to do. And then we look at the y, and what are we going to do with this guy? It's going to stay there. It has no negative x. Well, first off, it has no one else to go with. There's no y's downstairs for it to interact with, right? And then the only thing I might do with a straggler like that is if it had a -8 for its power, then I would move it downstairs. But since it's +8, I just leave it alone. And so in a case like this, it turns out I didn't need a fraction at all because no one winds up having to be downstairs. Done. You killing it? Good. Uh-huh. Yeah. You would distribute the exponent. Yep. Let me, well, hold on. I'm gonna, got it. So basically, I'm going to copy the problem down, and you're probably going to want to know if I actually have lost my mind. But I'm going to copy it right off the paper. Oops, sorry, that's a mess up. It just goes away because that's what I wanted to talk about, is that when you have something to the power of 0, generally it serves no purpose. Like putting 1 times all that stuff there, because that's what it equals is 1. It's so we don't put that. Okay, good, good, good. And then on the bottom, I'm just going to copy that down to
I know you're supposed to be right now.
so at this point, it's time to distribute our exponents, right? So when we do that, we're going to get 2 to the 4th and then x to the 8th. And then we're going to put that all over 2 to the negative 3rd, x to the negative 3rd, and y to the negative 6th. Don't. And we talked about this yesterday, and the only reason I didn't want to confuse you, I could have simplified this one, the yellow one, just for the record. And I thought about it, but I just wanted to tell you, at this stage in the game, you understand why we can solve the 2 to the 4th and get 16, but we can't solve the 2 to the negative 3rd? Like, what's the difference? It's not negative 6. We got to train that immediately out of your thinking. Negative exponents are not what you think they are. First off, like 2 to the 3rd is 8, but even if it was 2 to the negative 3rd, it's not negative 8. Negative exponents do not make answers become negative. They just make them move. So that's why we don't try to solve them as we go. Okay? And it's certainly not a negative number. So I'm going to just leave everything like it is right now. So ready? So here's what I can say about this. I've got some numbers up top, and I've got some numbers down bottom. We can do this a lot of different ways in this case, but they both have a base of 2. And so because they both have a base of 2, we can actually use the property of exponents because the bottoms are the same. The bases are 2s, they're matched. So if you wanted to, you could do 4 minus negative 3, 7. 4 plus 3 is 7. So you wind up with 2 to the 7th if you do it that way. You could also pick this one up with your bare hands and move it upstairs. Because that's what we do when something has a negative exponent, is we move it. Listen, you can either move it up if it's down or move it down if it's up. Like there's nowhere else. Things are trapped in this little case. They either go up or down. That's it. That's all they can do. So because he has a negative exponent, he moves upstairs. And when he gets there, he has to change his name from 2 to the negative 3rd to 2 to the 3rd. No, it would be 2 to the 7th. You don't multiply the bottoms when you use your properties of exponents. 2 to the 3rd, like it would be like if I gave you x to the 3rd and x to the 4th, that wouldn't be like 2x to the 7th, right? You wouldn't do that. It would just be x. Well, I'm just saying, like, it doesn't, you don't. So if you look at my yellow example down here, you don't change what that is. So you would not change what these are. That's what I'm saying. So there is no 4 in this problem. There's just 2 to the something and 2 to the something, which gives you 2 to the something else. Make sense? So we wind up on top with 2 to the 7th. Shut the door, please. Still good? Okay. And then we wind up with x to the 8th. And then we're going to put it over x to the negative. And I'm just showing as much work as I possibly can here. So this is where we currently sit, is right here. Good to hear? Yep. At this point, you have to do math. Like you have to take now, and there's nothing else to do with the 2s other than figure out what they equal. Like no one moves anywhere, no one combines. 2 to the 7th equals 128. 2 times 2 times 2 times 2 times 2 times 2 times 2 is 128. So we wind up with 128 right there. Done. Like that's not going anywhere. And now we're going to combine our x's and combine our y's and see what happens. So you see that there are x's on top and bottom. So we have to do 8 minus -3, which is 11. So we wind up with x to the 11th on top. And then we have a straggler, and that's this purple guy. I call him that. It's probably not the right term, but he's got nowhere to go and nothing to do. He's got no one to combine with. He's a man without a country, right? So we have two choices. We can leave him where he is and just wash our hands of it, or we can move him. In this case, we have to move him because we can't leave him in there. Why not? What's wrong with him? His exponent's negative. And you can't leave things with negative exponents. And so in this case, we're not using any subtraction or math to figure this out. We're just saying, well, we can't leave you like you are. And so it moves upstairs. And then we wind up not even needing a fraction at all. It just winds up looking like that. I hope that makes a little bit of sense. So the good news here is that there's a lot of steps that we don't need to do, because generally the first part of the problem is cleaning up the top and cleaning up the bottom, and the top and the bottom are done. So like I can't do anything else across the top. There's no parentheses, there's no like things to go together. So I'm ready to do the uppy downy thing now. So I'm going to begin with the number 2. And when I look around the problem, he has no one else, right? There's no other numbers, right? Remember, we're not allowed to call this a number or this number. Those are called exponents. And so I just look for normal numbers like sitting out in the open that I could multiply or divide him by. And I go, well, there's no one else. So we know for sure that the answer is going to have a 2. We clear? Yeah, the 1. Everything has an exponent, right? If you can't see it, it's a 1. So let's go alphabetically. Let's do our M's first. Hey, can I have a couple? Did you guys hey, you guys are getting too loud. I know that for you, you think class is done. I'm trying to get one more thing done, so knock it off. Thanks. So I'm going to take the M on top, which is 4, and the 1 on bottom, which is -1. And what's 4 minus -1? Sorry. So we get M to the 5, and since it's positive, put it on top, right? And then we're going to do it for the ends. We're going to go 4 minus 1, which is, and since it's positive, it's going to go. And so again, I drew this fraction, but it turns out I really don't need it, right? Better? Okay. Was that your only issue, was the invisible exponent? Okay.